Good morning, student friends. Up till now, in Unit 4, we have completed the introduction to conventional farming processes like hot working, cold working, their advantages, limitations, applications we have covered, and we have started the forging process. In that, we have covered introduction of the forging, again how this process has been carried out. Today we will see advantages of forging over other manufacturing process. First advantage, forged products are tougher than the alternatives. Alternatives means we can produce the product by machining, casting, or any kind of other forming process or joining process, but the parts produced by this forging process is a tougher. Their toughness is more, will handle impact better than the casting. Impact sustainable capacity of this forged component is more as compared to cast parts. That is the second advantage. The nature of forging excludes the occurrence of porosity, means whatever defects are occurring in the casting process like porosity, blowholes, shrinkage cavity, hot tear, cold shut, misrun, lack of poor short cavities, all these defects are not occurring in case of forging process, but these defects are occurring in case of casting. Tight grain structure of forging make it mechanically strong. The grain structure of forged component is tight as compared to cast and machining. In the last lecture also we have seen the grain structure is exist in a case of forging component as compared to casting and machining. That's why the parts are strong. There is less need of expensive alloys to attain the high strength components. Means very important property. If I want to select a material for a particular application which is having a more toughness and the cost is also more, these are the expensive alloys, but I can use low cost alloys, and by using forging process I can increase their toughness so that I can save the cost required for the materials. That is, use of expensive alloy you can diminish or you can minimize so that you can use the normal alloy components by using forging operation. The tight grain structure offer greater wear resistance. Wear and tear resistance of this forged component is more as compared to machining and casting without making any kind of heat treatment. Means generally carburizing, nitrizing or hardening heat treatment are required on the surface to increase its wear resistance, but without using any kind of heat treatment you can make the component wear resistance if it is produced by a forging operation. High strength for safety, security and long term applications. Whatever crane hooks, railway hooks we have seen, connecting rod of the IC engine or forge any kind of like a spanner, all these components they are having long term application, their safety is there. Near need shape to reduce the material cost. Consider half mold, half cavity, half die cavity which is attached to the punch, and half die cavity which is attached to the anvil. In that we are compressing the material, and the final product shape is die synced, means dies are manufactured by die sinking operation. That's why near need shape is produced and very less scrap is generated in case of forging operation. Consistently tight dimensional tolerance and more intricate details are produced. In case of machining we have to keep extra material on the surface of cast part, that will be removed by the secondary machining. 2 to 3 mm material is kept extra on the cast part. Again this is not required in case of machining. More intricate details you can produce. Elimination of porosity defect which is occurring in case of casting is eliminated completely. Lightweight with exceptional strength, you can produce the component which is lightweight and its strength is also more. Surface finish is good so that you can add the cosmetic value to the product, but surface finish is poor in case of casting. We have seen because adhering sand and oxide scales are present on the surface of cast part. Superior polishing and finishing surface characteristics are also present on this forging, which is not possible to achieve by other manufacturing process like a casting. Efficient production method and component reduction. This production process is fast, so that you can reduce the production time as compared to casting, because in case of casting many steps are involved, so time required for the production is more in case of casting, which is reduced in case of machining. All these are the advantages of forging process over other manufacturing process like casting and machining. Now we will see the classification of forging process. Mainly this forging process is classified into 4 types, that is hand forging, machine forging, cold forging and hot forging. Hand forging means this hand forging operation is suitable for the small products, means the tools which are made by the blacksmithy person by coming at our village or at our home, these are called as a hand forging. म्हणजे गावाकडे जे ब्लॅकस्मिथी पर्सन येतो खुरपं कोयता नंतर टिकाव कुदळ बनवण्यासाठी, ऑल दीज आर द hand forging products. Their capacity, their size is small, again number of products are less, and various hand forging tools are required, that is anvil, tongs, again small furnace is required to operate that hand forging. In case of machine forging, large components are produced by using hammers and the presses. Generally we are using hammer from capacity of 15 ton to 3500 ton capacity hammers we are using. Here dies are required. For the machine forging we need to have the upper die and lower die, and in between the two dies you have to compress the workpiece or you have to hammer the workpiece. This is machine forging. Cold forging means increased strength due to strain hardening. Deformation or the forging operation, if it is carried out at normal room temperature, it is called cold forging. I told you the example of cold forging is manufacturing of head of the bolt. Cold forging is also called as a cold heading. Here in case of cold working processes, I told you the material has very less tendency for the deformation, that's why it is opposing to the externally applied force, that's why strength increases, and that effect is called as a strain hardening effect. If material becomes a strain hardening, then it is very difficult to achieve its deformation furthermore. त्याच्या पुढं त्याचं डिफॉर्मेशन करणं हे अवघड जातं. त्याच्यामुळं स्ट्रेन हार्डनिंग झालेला कंपोनंट यू हॅव टू प्लेस इन द फर्नेस and you have to carry out annealing heat treatment so that material will become a soft, its ductility will be increased, and further you can go for the forging operation. Increase the strength due to strain hardening, that is the feature in case of cold forging process. Reduction in strength and increase in ductility of the work material. In case of hot forging, forging process is carried out by heating the workpiece above the plastic deformation temperature or above the recrystallization temperature. That's why strength decreases as well as ductility of the material is more. Impact forging, forging hammer applies an impact force. Suddenly we are applying blows of hammer on the surface of workpiece which is kept in between upper die and lower die, and after each blow of the hammer you are achieving certain amount of deformation, and after 7 to 8 blows of the hammer you will get a complete product, that is called as a impact forging. In case of press forging, we are applying the pressure gradually, means there is no any kind of impact. These are the types of forging we have seen. Again we will continue with that types of forging according to the, this classification is made according to the symmetry of the dies, whether die is open die, impression die or fleshless forging. First is open die forging. Work is compressed between two flat dies, means in a case of open die forging the dies are completely flat. The dies does not carry any kind of design. त्याला कुठल्याही प्रकारची डाय कॅव्हिटी नसती. डायज आर फ्लॅट ॲज लाईक अ प्लॅटफॉर्म ऑफ द टेबल. आपल्या टेबलचा जसा प्लॅटफॉर्म असतो तसा डायचा सरफेस असतो. इट इज टोटली फ्लॅट, अलाविंग मेटल टू फ्लो लॅटरली विथ अ मिनिमम कन्स्ट्रेंट. मेटलला कॉम्प्रेस केल्यानंतर त्याला कुठल्याही प्रकारचं कन्स्ट्रेंट नसतं. म्हणजे हियर धिस टाईप ऑफ फोर्जिंग इज अ जनरल पर्पज फोर्जिंग. एखादा आपला बिलेट आहे, ब्लूम्स बिलेट्स आय टोल्ड यू, देज आर हॅविंग अ स्क्वेअर क्रॉस सेक्शन अँड स्लॅब इज हॅविंग अ रेक्टँग्युलर क्रॉस सेक्शन. मग हा मोठा स्लॅब आहे तर दॅट स्लॅब यू कॅन प्रेस बिलो द ओपन डाईज so that you can gradually decrease the thickness of that slab and you can increase its length in a proportionate manner. That is the open die forging. Impression die forging means die contains cavity or impression that is imparted to the work part. Now in case of open die forging, dies are totally flat In case of impression die forging, die cavity is machined to the dies. Upper die आणि lower die ला cavity machine केलेली असते, impression तयार केलेलं असतं, and that impression you have to give to the metal in the red hot condition. This is the impression die forging. That is impression die forging. Metal flow is constant so that flash is created. जेवढं मेटल आहे तेवढं कंप्लीट फ्लो झाल्यानंतर एक्स्ट्रा मटेरियल विल कम इन बिटवीन द अप्पर डाय अँड लोअर डाय. 100% डिफॉर्मेशन झाल्यानंतर जे शिल्लक राहिलेलं मेटल आहे ते दोन्ही डायच्या मधून हॅमरिंग केलं की बाहेर येतं. इन बिटवीन टू डायज द मेटल विल कम अँड दॅट इज कॉल्ड ॲज अ फ्लॅश, अँड दॅट फ्लॅश इज प्रोव्हाइडिंग द कुशनिंग इफेक्ट इन बिटवीन द अप्पर डाय अँड लोअर डाय. जे शेवटचे 1-2 हॅमर आहेत, म्हणजे 8-9 हॅमर नंतर कंप्लीट प्रोडक्ट तयार होतो, शेवटचे 2 हॅमर आहेत त्याला डायरेक्टली 2 डाय एकमेकावरती जोरात आदळण्याची शक्यता असते. आणि जर डाय तसे आदळले under a pressure of 15 ton to 3500 ton, there may be chances of wear and tear of that dies. And to avoid this flash is playing a very important role, that the flash is providing the cushioning effect in between the upper die and lower die. Now last type is a flashless forging. Work is completely constant in the die. This is one type of a closed die forging. Flashless means whatever scrap is produced in case of impression die forging, that scrap is also not produced by using a flashless forging. But म्हणजे इथं फ्लॅश तयार होत नाही, that's why it is called as a flashless forging. And this forging is very important because we have to calculate the volume of the metal before it is placing inside the die cavity. Die cavity मध्ये ठेवायच्या अगोदर त्या मटेरियलचं व्हॉल्यूम कॅल्क्युलेट करणं गरजेचं आहे. अँड इट इज डिफिकल्ट टू रिमूव्ह द वर्कपीस आफ्टर इट्स मॅन्युफॅक्चरिंग. तो प्रॉडक्ट तयार झाल्यानंतर बाहेर काढणं हे अवघड जातं. दॅट इज द फीचर ऑफ दिस फ्लॅशलेस फोर्जिंग. यू कॅन सी बाय टेकिंग द रेफरन्स ऑफ द पिक्चर, यू कॅन सी द फर्स्ट A figure is for open die forging. You can see that upper die and lower die, these are completely flat, they are not carrying any kind of design or impression or any kind of grooves, and material is not constrained. Material तुम्ही lower die is fixed on the anvil, and upper die is continuously moving in the upward and downward direction, and pressure is applied or force is applied on this workpiece in the red hot condition. Now here material will flow, means material does not have any kind of constraint in case of open die forging. You can see the figure, this is second figure is for closed die forging. You can see constraint is provided to the material. After each blows of the hammer from the upper side, you will achieve certain amount of deformation, and at the end, after complete deformation, flash is created and which will moving in between the two die. दोन डायच्या मध्ये फ्लॅश येतो. This is called as a closed die forging. Impression die forging. And last one is the flashless forging. Here flash is not created. You can see, I told you the material is a constraint from all the sides. Material ला बाहेर यायला कुठल्याही प्रकारची इथं जागा नाही. But it is difficult to remove this product after it has been made. Complete deformation झाल्यानंतर पंच ज्यावेळेस आपण वर काढून घेतो त्यावेळेस हा प्रोडक्ट बाहेर काढणं हे डिफिकल्ट जातं in case of flashless forging. Here flash is created and here flash is not created. That's why it is a flashless forging. These are the types of forging. Now we will see its difference, comparative points we will see. Open die forging चा advantage काय बघा. This open die forging process is simple in operation. Just दोन die आहेत, upper die, lower die, त्याला कुठल्याही पद्धतीचे डिझाईन नाहीत. That's why it is simple in operation. Suitable for low volume production, low cost of tools. इथं डायज वरती कुठल्याही प्रकारचं मशिनिंग करायचं नाही, त्याच्यामुळं कॉस्ट ऑफ मेकिंग दॅट टूल इज लेस. बट लार्ज जॉब्स ओनली कॅन बी हँडल्ड बाय द ओपन डाय फोर्जिंग. लार्ज जॉबसाठी ओपन डाय फोर्जिंग हे सुटेबल आहे. इम्प्रेशनमध्ये काय व्हरायटी ऑफ शेप्स कॅन बी ऑप्टेंड. एनी टाइप ऑफ इम्प्रेशन you can machine to this open die and lower die combinedly, and you can produce that component. Grain flow as per requirement. Grain flow is very important part in case of forging. Grains means crystal structure is achieved in the direction of the blows of the hammer. That's why strength and toughness of that part is more. That is the grain flow is very good, is achieved in case of impression die forging. High strength of the product is achieved. Correct neat final shape of the product closed die forging मध्ये, or also called as a flashless. Final shape is achieved to the product. इथे impression die forging मध्ये ट्रिमिंग एक ऑपरेशन आपल्याला करायला लागतं. ट्रिमिंग मीन्स टू रिमूव्ह दॅट फ्लॅश, and here trimming is also not required. Final shape you are achieving in case of flash ledge forging. Very high strength is obtained and grain flow is as per requirement. This is the flash ledge forging. फर्स्ट लिमिटेशन काय, सुटेबल फॉर द सिम्पल शेप्स, म्हणजे जस्ट तुम्हाला सर्क्युलर शेप आहे त्याचं कॉम्प्रेशन करून अँड आफ्टर ईच कॉम्प्रेशन यू हॅव टू रोटेट दर वर्क पीस सो दॅट यू कॅन अचीव द स्क्वेअर शेप और द rectangular shape. In simple shapes you can go for, in case of open die forging, less dimensional accuracy, low material utilization, large scale generation, less control on the grain flow, and skilled workers are required. Means where we have to apply the blows of the hammer, for that purpose skilled worker is required, and grain size is not controlled in case of this open die forging. In case of impression die forging, high cost of dies, large capacity hammers and presses are required. Remove of the flash is required, and for removal of the flash we are using a trimming operation. Control on temperature of the billet is essential, and this is required in both the cases. Control of temperature is required in case of flash ledge forging as well as impression die forging, because as and when temperature drop takes place, you have to apply the exothermic chemical compound powder on the surface of that metal, so that reactions, due to reaction heat is developed, and that heat we have to utilize to increase the temperature of that raw material above the recrystallization temperature, so that control of the temperature is very important in case of impression die forging or flash ledge forging. Here very high cost of the dies. Here dies design should be such that it is easy for us to remove the product after its complete deformation. Large capacity hammers are required in case of this flash ledge forging. Removal of product from the die is critical. I told you at the start only. Now we will see the applications of this open die, impression die and flash ledge forging. Application: disc, hub, block, shafts, sleeves, cylinders, flats, hexes, rounds, plate. All these are the couplings. All these are the examples of this open die forging. These are the simple components as compared to flash ledge forging. Highest critical components we can produce by this flash ledge forging, that is third type. In case of impression die forging, we can manufacture spanner, connecting rod, crankshaft, firearms, agricultural products, again kick used for the starter, tie rods. All these are the products made by the impression die forging. And last, valve bodies, steering rod, crane hook, again gear blanks, tappet rod, crank levers, cramps, rocker arm. All these products are made by the flash ledge forging. This is advantages, limitations and applications of the open die forging. Again, impression die forging and closed die forging. We'll stop here. In the next lecture we will see next part.